Okay, let's go. Quiet, please. Quiet. Okay, so we're going to go through the review step by step. Some of these questions are questions which I would call knowledge questions that you should know. I mean, it's the kind of things that are like good, true, false questions or fill in the blank or something like that. And not just be so focused on process, like, oh, I see what's in front of me there. Remember we did this in class. I don't know why I'm doing it, but I'm just going to do it. Right? So you got to try to understand the concepts, not just, oh, here's another thing to memorize, which I really don't understand. That's why things get harder as you go along, because you can't remember everything. Right? If you try to make sense of it, remember what it really means, then you won't have that issue. So what is a polynomial? What might it have? Go ahead. Well, the word means many terms, right? Polynomial. And what do you usually see? Well, a polynomial can be 1 term, 2 terms, 3 terms, 4 terms, anything. And generally it's a bunch of numbers and letters and things like that, right? So numbers, variables, or products of numbers and variables, or the sum of products of numbers and variables, right? Even a constant is a polynomial, right? So 2 is a polynomial, x is a polynomial, 2xy is a polynomial, 2x plus y is a polynomial. The main thing is that the exponents of the variables have to be whole numbers, right? They're not going to be negative numbers. They're not going to be fractions. Right? The last two that I've got up there have 2 terms, right? Because the terms are separated by pluses, right? And in one of the terms, there's a variable and a number, right? When there's a number in front of the variable, that's called a coefficient, right? That's a vocabulary word that we use. You got to know what it is. Okay. Okay. So how do we classify polynomial? By degree and number of terms, right? First, we classify it by the number of terms. If it has 1 term, we call it a monomial. If it has 2 terms, we call it a binomial. If it has 3 terms, we call it a trinomial. And if it's 4 or more, we just say polynomial. Again, terms are separated by pluses or minuses, right? I keep saying that plus, everybody knows that's an addition. Sometimes a negative sign, can be confused with a minus for subtraction. So make sure that it's actually a subtraction going on. So these are all examples, right? Monomial, 2x squared, binomial, x plus 3, trinomial, x squared minus 5x plus 4, and the cubic is at the bottom, 4 terms, polynomial. Classify it by degree, right? By degree, a term has a degree. The degree of a term is what's the exponent of the variable. The polynomial's degree is the degree of the highest degree term. With examples, right? A 0 degree is a constant term. I mean, like the number 2, just by itself. We can think of that as 2 times x to the 0. What does x to the 0 equal? What is is 1, right? Anything to the 0 is 1. That's why we don't write it there. Nobody would ever write 2x to the 0. But we can consider the constant by itself to be a 0-degree term. Linear means that the variable is raised to the first power. Quadratic means it's raised to the second power. Cubic means it's raised to the third power. And while we have words for above that, don't worry about them. You know, I did say in class quartic. Okay, the problem is that you guys end up confusing quadratic and quartic. You know, when you're classifying degree on the quiz, you're classifying something that's a quadratic. You're telling me quartic. So just forget about the quartic. Quadratic is the one you need to know. Okay. So classify by degree and number of terms. Right? By degree, the first one. What do we say when it's a 4 and above? Just say 6 degree. And by number of terms, has 2 terms, binomial. How about the next one? 5th degree. By number of terms, it has 1 term, so it's monomial. How about the next one? What's the degree? What's the highest power term? Don't look, this one's not in standard form. Keep looking. Where's the highest degree term? It's actually at the end. Right? So what do we call it if it's 4th degree? I just told you call it 4th degree. I mean, it is a quartic, but we'll call it 4th degree. And then by number of terms, what will you say? Because it's 4 terms, we said 4 terms or more, just say polynomial. Now, how about the last one? By degree, we would call it, it's squared, but we have a word for that. Quadratic. Quadratic. And it has 3 terms, so we're going to call it trinomial. Good. Okay, next. So, how do we add or subtract polynomials? Right? We combine like terms by adding or subtracting the coefficients. Remember, like terms have the same variables raised to the same powers. We're good? Everybody's good? So, on the first one, again, do the parentheses make any difference when you're adding polynomials? No. If you took them away, everything would be the same, right? I mean, it's when you subtract, parentheses make a difference. So if you need to, you could take a step and get rid of the parentheses, but mainly you just need to combine like terms. And try to write your answer in standard form. So what's the highest degree term that we're looking at in the first one? It looks like 4th degree. Okay, so let's combine those terms. What's negative 4k to the 4th minus 3k to the 4th? Negative 7k to the 4th. Okay, let's see. Is there a k to the 3rd term? No, so let's go to the k squared terms. Okay, what's 3k squared minus 14k squared? minus 11k squared. Okay, is there a k to the first term? No. So the constant term, 14 minus 8. 6 plus 6. Okay, and then when you get to the subtraction now, parentheses make a difference. And you could deal with it without getting rid of the parentheses, but you got to remember, like this fifth degree term, 12a to the fifth minus negative 2a to the fifth would be like 12a to the fifth plus 2a to the fifth. You know, what my experience is, you're going to make some mistakes doing that. So I would probably rewrite it without the parentheses. 12a to the fifth minus 6a minus 10a to the third minus 10a plus 2a to the fifth and plus 14a to the fourth. So what's the highest degree term going to be in our polynomial? It looks like 5. Okay, what's 12a to the fifth plus 2a to the fifth? Looks like that's 14a to the fifth. Okay, do we have any a to the fourths? And it looks like just 1, so that's plus 14a to the fourth. How about any a to the thirds? Yeah, just 1, so minus 10a thirds. How about squared? How about linear? Yeah, you got a negative 6a minus 10a, which is negative 16a. And there's no constant. Done. Okay, remember, whenever you're combining like terms, don't change the powers, right? Don't change the exponents. That's kind of apples and oranges wrong at that point. They're just going to lose all the credit. And when you get something like this, I mean, stop, right? Stop. Don't try to keep going. Okay, how do we multiply polynomials? Well, there's 3 kinds of multiplying that we do. The first is multiplying by a monomial. Right? If you're multiplying by just one term outside parentheses, that's distributive property. Right? That's a property you already know. Essentially, we got to make sure for all of this that we're sure that we multiply every term in one polynomial times every term in the other polynomial. Right? Again, if one of the polynomials is a monomial, you're just using distributive property. That should do it. Good. So let's do a couple. Right? There's a couple where we're multiplying parentheses by one term on the outside. Okay, so how do I do 6b times 2b? Nope. V times v is v squared, right? And then 6v times 3, 18v. Now, getting a little ahead of ourselves here. Again, that's the kind of thing that we would do greatest common factor factoring on, and we would end up with where we started, right? Those are just opposite things. Factoring greatest common factor and multiplying by a monomial, that's like inverse operations. How about the next one? 2x times negative 2x. Negative 4x squared. 2x times negative 3. Negative 6x. Ready? Okay. How about if we're multiplying a binomial times a binomial? 2 terms times 2 terms. You definitely could use FOIL, right? FOIL is almost designed to do that one thing. Multiply a binomial times a binomial. Good. So, again, what does the FOIL stand for again? FOIL. First, outer, inner, last. Okay, so what do I get when I multiply the first terms here? 12n squared. What do I get when I multiply the outer terms? Plus 2n. What do I get when I multiply the inner terms? And what do I get when I multiply the last terms? Plus 2. Okay, but I still have one step. What is it? Yeah, you got two terms that are like terms. The 2n and the 12n, they could be combined, right? Because they have n to the first. That's almost always the case when you FOIL, right? There's something, the inner term, the o and the I, they come together. So that'll be 12n squared plus 14n plus 2. Okay, how about the next one? First, outer, inner, last. Right. Okay, last step, combine like terms. 6x squared minus 20x plus 6. Right, so 2 terms times 2 terms. FOIL is a good way to go. Right, when you get above 2 terms times 2 terms, then you probably need a different process. I mean, FOIL itself is only going to give you 4 multiplications. Right? I mean, this is the most we would have to do, is a binomial times a trinomial. And then we'll use the grid like we did on the quiz, or should have done. So multiplying a binomial times a trinomial. In the book, if you see their example, they call it a table of products. I always called it a grid. Good. We're good. Victoria? Breathe. Okay. Okay, so let's try to do this one, kind of like a you try. Could you fill in the squares like that? We get the same thing? Let me get rid of these little dots. Well, that counts for a little, I guess. I hope it's right. Okay. Okay. So you should have got all those 6 squares filled in and got exactly those. And now, what's the last step? You got to combine like terms, right? Now we're adding polynomials, basically. So this is 24, a to the third. How many a squareds are there? 3. Incorrect. 8. 12a squared minus 4a squared is 8a squared. What's negative 2a plus 8a? Positive 6a. And then we've got the 4. Done. So remember that if you use that method, which to me makes things a lot easier, you could use that instead of FOIL too. Right? You could make yourself a little 2x2 grid and fill it in. And just always just use one method. Don't worry about, when sometimes in the book, when you go to the homework problems that I'll give you even today, they talk about like vertical method and horizontal methods and different things. It doesn't have to be that complicated. Just try to stick with one method that works for you. They show this method too, right? This is the first one they show. Okay. So what do we mean by factoring a polynomial? Factoring is the process of converting a polynomial in standard form to a polynomial in factored form. It's kind of the opposite of multiplying, right? Is to factor. Okay. So now we're going to go through the different kinds of factoring. That'll be the end of the review for today. I'll give you the homework to work on. Okay. So the first and most important kind of factoring we do is greatest common factor. It's most important because you always have to check for greatest common factor. Before you do anything else, check for greatest common factor. Okay. So, first one. What's the greatest common factor between 12v squared and 18v? 2 is a common factor, but it's not the greatest common factor, right? 6 is. Okay, but there's more. There's a v, right? Just think of it when you're saying 12v squared and 18v. You just said v twice, okay? So that's in common. So you got to take out a v. Okay, what's left if I factor 6v from 12v squared? 2v. What's left if I factor 6v from 18v? Plus 3. Okay? Again, now what does that look like? That looks like multiplying by a monomial, right? That is actually one of the problems that I did before, multiplying by a monomial. The next one is not. What's the greatest common factor between negative 35v and negative 56? A little bit more. Negative 7? Okay, what's left if I factor out a negative 7 from negative 35v? 5v plus 8. Okay. So remember, greatest common factor, you should check for it every time before you start. Okay, simple quadratic trinomial, right? Why do we say it's simple? It is easy. Because it's only one step. What is it that tells you all of those are just going to be this one-step process? Simple quadratic trinomial. Sorry, if you were still copying that, the only thing it's added is the simple quadratic trinomial. You know, and we should know what it means, quadratic trinomial, right? It means highest power is 2, 3 terms. And again, what is it that makes all of these what I call simple? I took these off, I take all these problems from these CUDA. CUDA is a K-U-T-A website that has got free math worksheets, and they call it easy and hard. I always say simple and not simple, but easy and hard is fine. You know, what is it about all these that tells you this is a one-step process, not a six-step process? There's a 1 in front of the squared term, which means you don't see it, but it's there. Right? Whenever that's the case, this is going to be a one-step process, right? So let me undo all those. Okay, now what is the thought process behind factoring something like this? What two numbers are we looking at?
The middle and the left.
Right. Okay, so in your mind you're saying, what are the factors of 7 that add up to 8? Right? Factors of 7 that add up to 8. Okay, well, what would they be? 7 and 1. So the factoring is b plus 7 times b plus 1. It's a one-step process. Once you've got those numbers, right? How about, I didn't even notice that these two are so similar. A squared minus a minus 90. What are the factors of negative 90 that add up to negative 1?
So that means 1 and 2. Wait, what's 2 going to be? The 1 and 2. Right?
You know, we can go through 1 times 90, 2 times 45, 3 times 30, 4 no, 5 times 18, 6 no, 7 no, 6 yes, 6 times 15. Yeah, and then you're going to get to 9 times 10. Now, because this number is negative, right, the negative 90, we know one of those factors is negative. Which is going to be the negative, the bigger or the smaller? The bigger's got to be the negative. So if we put a negative in front of all of our bigger factors, and then say which one of these is going to add up to negative 1? 9 and negative 10. So what are the factors? A plus 9, a minus 10. Okay, what about this one here, the m squared plus m minus 90? Right. Well, say it again. How about m negative 9 times positive 10? Because this time they add up to a positive number. Right, it's the only difference. So m plus 10, m minus 9. Okay, how about the last one? The factors of 10 that add up to negative 11. Yeah, I mean, since the last number is positive, you know that they're either both positive or they're both negative. Since the middle number is negative, they're both negative. So it could be 1 times 10, or negative 1 times negative 10. It could be negative 2 times negative 5. Which one of those adds up to negative 11? That one. So this is n minus 1 times n minus 10. We're not done yet. Okay? We have the not simple, the hard quadratic trinomial. We good? Not much to copy there. Okay, so what is it that makes these hard or not simple? Yeah, this 5 there means you can't just say what are the factors of 12 that add up to 19. It isn't going to work, right? What do we have to do instead? Say again, Katie? You got to say 5 times 12, which is 60, right? And then find the factors of 60 that add up to 19. How can we find factors? What if you're not good at you don't know your multiplication tables very well? You're going to stumble at this every time. How can you use your calculator to help you with this? Yeah, remember, this is the way you can help yourself with that. Y equals clear. Right, on Y1, let me put 60 divided by X. And then go to the table of values. Well, let me set the table to, second table, to start at 60. Right, so now when I go to the table of values, right, obviously 60 times 1, that's there. Then we start dividing by all the numbers less than 60, right? When we have a decimal, we know we didn't find a factor. When we have a integer, whole number, okay, there we go, 30 times 2. 30 times 2 is 1. Okay, we got 20 times 3. 15 times 4. 12 times 5. 10 times 6.
I found it.
And that's it. So which are the two of those that added up to 19? 15 and 4. Right there. So we're going to use 15 and 4. So what do we do with those two numbers? No. Tate, pay attention. What do we do with those numbers once we get them? Remember, this is not a one-step process. You have to split up the middle term, right? You've got to make this 5n squared plus 15n plus 4n plus 12. All right, what's the next step? Group the first two terms and group the last two terms. 5n squared plus 15n, n parentheses. Make sure that plus is in between the parentheses, like that. Okay, and then what kind of factoring do we do on each set of parentheses? Greatest common factor. Okay, what's the greatest common factor between 5n squared and 15n? 5n. Okay, what's left in parentheses if I factor out a 5n? n plus 3. Remember, you can do that off to the side. You could say, what's 5n squared over 5n? And the 5's cancel and one of the n's cancel. And what's 15n over 5n? And the n's cancel and 15 over 5 is 3. Okay, plus, what's the greatest common factor between 4n and 12? 4. N plus 3. Okay, what do you notice now? Okay. You have the same thing in parentheses. If you don't have the same thing in parentheses, you did something wrong, basically. Okay, it should be the same thing in parentheses. Now, we're going to take away n plus 3 from both of those terms, right? What's left if I take away the n plus 3? Yeah, the 5n and 4. Right, 5n goes there, 4 goes there. Okay, now the next one, I'm not going to use that 6-step process because I can see that the first number and the last number are both prime numbers. I mean, 2 only has factors of 1 times 2. So maybe we could just guess and check here. Let's see. If I can say for sure that the first thing in parentheses should be 2n times n. Okay, what are the possibilities for what comes after. What are the factors of the constant 2? 1 and 2, right? So it's either got to be 2n plus 1 times n plus 2, or 2n plus 2 times n plus 1. Which one of those, if you FOILed it, would you get 2n squared plus 5n plus 2? Let's see, the second one, I would get 2n times 1, which is 2n, and 2 times n, which is another 2n. That's 4n. So that's not right. Okay, now try this. 2n times 2 is 4n, and 1 times n is n. There's your 5n. So without having to go through all of those steps, you might be able to guess and check an answer, especially if the first number and the last number are prime numbers. So just a thought. Okay, difference of squares. All right, you're almost done. Difference of squares. Well, there's just review. I mean, you already took notes on all this stuff. Okay. Okay, difference of squares. What does it mean, difference of squares? What difference means subtraction, right? And squares means perfect squares. So remember, the formula for it, because there is somewhat of a formula for it, is this. A squared minus b squared, difference of squares, equals a plus b times a minus b. So n squared minus 25 is not written like a difference of squares. But isn't 25 a perfect square? What number squared equals 25? So we should write n squared minus 5 squared. Okay, now it exactly matches this pattern. So how does it factor? N plus 5 and minus 5. How about the next one? Not written as a difference of squares, but aren't both 16 and 9 perfect squares? So let's write it as actual difference of squared. Not 4 squared, 4n squared minus 3 squared. Okay, now what are the factors? 4n plus 3, 4n minus 3. That's difference of squares. Yes. You just stretching again? Okay. Last one. Perfect square trinomial. Okay. Perfect square trinomial. So the perfect square trinomial also has its own formula, which is this. A squared plus 2ab plus b squared equals a plus b in parentheses squared. So if you have a perfect square trinomial, it should be that the first term and the last term look like perfect squares. Do they? 16 and 25? Sure. So that would be 4b in parentheses squared. This one would be 5 squared. So the only question is, right, that's the 5 squared is 25, 4b squared is 16b squared. If it's going to match this pattern here, then it should be that the middle term is 2 times A times B. 2 times 4B times 5. So let's plug it in. Plus 2 times 4B times 5. What is 2 times 4B times 5? 8B times 5 is 40B. Okay. Now let's see, that the answer there is not 40, it's negative 40. So what do I need to change about this? You know, it probably needs to be that this last one here, it's actually negative 5 squared. Negative 5. So we can factor this. This is 4b minus 5 in parentheses squared. It's a perfect square trinomial. Kind of messy there. Sorry about that. I mean, the second one, if you look at it, again, it's certainly a trinomial, right? And it looks like the first term and the last term are squares. So you might think it's going to be a perfect square trinomial. I would think that it's probably going to be 2x minus 1 times 2x minus 1, which is 2x minus 1 squared. Well, let's check it out, right? 2x times 2x is 4x squared. 2x times negative 1 plus negative 1 times 2x is negative 4x. Negative 1 times negative 1 is 1. So it is 2x minus 1 squared. That's the least useful of all the ones that we get. And you know, you can do, like, let's say you understand that other process that we learned, you know, to do a not simple quadratic trinomial. I mean, you could just do that. I mean, in the end, you'll find that it's a perfect square trinomial. The problem becomes, if you did that method, you would have to go 16 times 25, which is 400. And that would probably cause some issues then at that point. Like, find the factors of 400 that add up to negative 40. Negative 20, negative 20. Okay? So that's the summary of all the methods we have for factoring are there. You've already written them all down, but wait. So you might want to write them down. GCF, simple quadratic, not simple quadratic. Difference of squares, perfect square trinomial. Okay, here's the homework. So we're gonna go over these next class. You're gonna grade your own. You don't have the answers. I'll give you the answers on Wednesday, and you'll check it off. We'll score ourselves. 22 or something problems, maybe 23. But a lot of them are basic, you know, classify by degree and number of terms. Simple.